Methane's bonds are considered sigma bonds because each carbon-hydrogen bond is formed by the direct end-to-end overlap of an orbital from carbon with an orbital from hydrogen along the line that connects the two nuclei. Think of the carbon atom like a little house with 4 identical rooms pointing toward the corners of a tetrahedron. And each hydrogen is like a friend standing directly in front of one room. When the room and the friend reach out straight toward each other, their hands meet head-on and make a strong single connection. And that straight-on connection is what chemists call a sigma bond. The carbon uses orbitals that are arranged to point outward evenly, and each hydrogen brings its single orbital to meet the carbon orbital directly between the two nuclei, so the electron density is concentrated right on that line. Because the overlap happens along the axis joining the carbon and hydrogen nuclei, the bond is cylindrically symmetric around that axis and does not change if you rotate the bond, which is another hallmark of a sigma bond. This direct head-on overlap is different from side-by-side overlaps that produce other bond types, so methane's single bonds are all sigma bonds. A common mistake is thinking any overlap makes a sigma bond, but only end-to-end overlap along the internuclear axis produces sigma bonds, so remember to check the orientation of the orbitals. Another misconception is imagining the bonds as rigid sticks. In reality, the bonded electron cloud is spread out along the axis and can shift slightly with vibrations, so do not picture them as immovable rods. A final error is assuming identical-looking bonds mean identical orbitals on carbon without considering hybridization. So recall, carbon's orbitals mix to form 4 equivalent hybrid orbitals that overlap with hydrogen. For more videos and resources on methane bonding and hybridization, check out www.gumballdegree.com.